Welcome to this course on Python for finance and algorithmic trading. My name is Jose Portilla and I'll be your instructor for the course. I teach over 200,000 students here on Udemy on topics such as programming, data science, and machine learning. And I also work as a corporate technical trainer for some of the world's largest banks and financial institutions. I'm excited to present this course to you as it's based off the same technical training material I've personally delivered at some of the world's top financial institutions. We'll be teaching you how to use the powerful Python programming language for financial applications and algorithmic trading. Let's get a quick overview of the curriculum. We'll start with a basic crash course in Python for a quick review of the programming language. Afterwards, we'll cover key libraries that we're going to be using in our analysis, including numpy, pandas, and matplotlib. Once we've learned the core libraries, we'll jump into learning how to work with time series data with Python, including working with the stats models library. We will also cover how to use Python to obtain financial securities data, including Pandas data reader and the quantopian API. Once we've mastered all these libraries, we'll continue by learning about Quantopian, one of the best platforms online for conducting algorithmic trading with Python. With this course, you get a variety of content, including high-definition video, explanatory code notebooks, as well as links to complete slide decks for each major topic. Not only do you get great content, but you also get access to our online question and answer forums inside the course, as well as our own Gitter chat room so you can talk to fellow students. This course also comes with a certificate of completion that you can post to your LinkedIn profile to show off to potential employers or your colleagues. All of this comes with a risk-free 30-day money-back guarantee. Check out the preview videos to get a better look at what is inside the course. Thanks for watching, and I hope to see you inside the course. Welcome to this course on Python for finance and algorithmic trading. Welcome to this course on Python for finance and algorithmic trading. My name is Jose Portilla and I'll be your instructor for the course. I teach over 200,000 students here on Udemy on topics such as programming, data science, and machine learning. And I also work as a corporate technical trainer for some of the world's largest banks and financial institutions. I'm excited to present this course to you as it's based off the same technical training material I've personally delivered at some of the world's top financial institutions. We'll be teaching you how to use the powerful Python programming language for financial applications and algorithmic trading. Let's get a quick overview of the curriculum. We'll start with a basic crash course in Python for a quick review of the programming language. Afterwards, we'll cover key libraries that we're going to be using in our analysis, including numpy, pandas, and matplotlib. Once we've learned the core libraries, we'll jump into learning how to work with time series data with Python, including working with the stats models library. We will also cover how to use Python to obtain financial securities data, including Pandas data reader and the quantopian API. Once we've mastered all these libraries, we'll continue by learning about Quantopian, one of the best platforms online for conducting algorithmic trading with Python. With this course, you get a variety of content, including high-definition video, explanatory code notebooks, as well as links to complete slide decks for each major topic. Not only do you get great content, but you also get access to our online question and answer forums inside the course, as well as our own Gitter chat room so you can talk to fellow students. This course also comes with a certificate of completion that you can post to your LinkedIn profile to show off to potential employers or your colleagues. All of this comes with a risk-free 30-day money-back guarantee. Check out the preview videos to get a better look at what is inside the course. Thanks for watching, and I hope to see you inside the course. Welcome everyone to the section on working with pandas with time series data. Now that we have an understanding of how to work with pandas for general data, let's go over a few key points of working with time series data with the pandas library. The majority of our data sets will be in the form of a time series. That is, it has some sort of date-time index and some sort of corresponding value per that date-time index. For example, some stock price for a particular date on the index. What we're going to be doing in this section is learning how to use Panda's special time series features to work with this sort of data. This section will cover the following. We'll talk about date-time indices, talk about time resampling, how to work with time shifts, and then we'll also discuss Panda's built-in rolling and expanding methods. Okay, let's get started. I'll see you at the next lecture. Welcome back everyone to the date-time index lecture. Often the time and date information in our financial data won't just be in a separate column, but instead it will be the actual index of the data frame. Let's discover the built-in Pandas tools for creating and working with a date-time index. I'll open up a new Jupyter notebook and get started. Alright, so to start off I'm going to do a couple of imports, and you can essentially just fast forward through these, or maybe you even already have them. But I'm going to import numpy as np, pandas as pd, and just in case we do any visualization, I'm going to import matplotlib.pyplot as plt. And again, in case we do any visualization, let me just make sure matplotlib inline because I'm using a Jupyter notebook. Okay, now built-in Python libraries for dates and times actually exist, and the one for Python is the datetime library. So without installing any additional libraries, you should just be able to say from datetime import datetime. And this is Python's built-in date and time library that allows you to create timestamps or specific date objects. So just to illustrate this, I'm going to create a couple of variables. I'll say my year 2017, and you can basically just make these up. We'll also create a month. We'll say the 1st, so that's January. We'll create a day of the month. We'll say that's 2. We'll also create an hour. You kind of get the idea here. And the hour, it's important to note, is going to be in the 24-hour format. That is, something like 1 o'clock in the afternoon or 1 p.m. is going to be written as 1300 hours. So my hour is going to be between 0 and 24 there. And then we'll have a minute. My minute, we'll say 30. And then we'll say my second is, let's say, 15 seconds. Okay, so a bunch of arguments there. So if you want to use Python's built-in date-time functionality, it's actually quite simple. You would just say my date is equal to, and then you would call datetime. And the thing to note here, and this is actually one of the complaints of Python's naming scheme, is that this datetime is being imported from the datetime library. So it's going to be like datetime.datetime. This is a poor naming convention, and a lot of people have complained about it, but it's kind of really built into Python, and a lot of things depend on it. So it is here to stay. Just keep that in mind that if you just say import datetime, it's not the same as from datetime import datetime. Okay, moving along, I'm going to create a datetime object, and if you do Shift Tab here, you should see the documentation string, and we can see that it takes in the year, the month, the day, and then it has additional arguments for the time. So let's start off with just day information. That is a date object, and I'm going to pass in my year, my month, and my day. You could also just pass these in as numbers. They don't have to be variables, but this is just for illustration purposes. That way it's really clear what the arguments are instead of just passing in numbers. So now that I have my date, if I take a look at this date object, I have datetime.datetime, and then I see 2017, January, that's 1, and then the day of the year, or excuse me, the day of the month, that's 2. And we can see that it also defaults to 0-100 hours. So it's important to keep in mind that if you don't provide some time information using datetime, it's going to default to 0 hours and 0 minutes. If you don't want that to happen, we could just specify my date time and then set it equal to date time, and I can actually just copy what's here, and then I'm going to add in additional arguments. So it goes year, month, day, and then you can add in things like hour, your minute, and then your actual seconds. And now if I take a look at my date time, it actually corresponds to the additional time information. And notice here in this original one, it just defaults to hours and minutes. It won't actually keep providing things like a default second or a default microsecond. Now what's important to note here is that this is not just a string or some sort of numerical object. If you take a look at the type of this object, so I'd say type my datetime, it is a datetime.datetime object. And that's really important because this datetime object actually has attributes that you can grab from. So I can say my date time dot, and then if you hit tab here, you'll notice there's a bunch of things you can do with it. There's also a lot of methods, but for now, let's just focus on the actual attributes. And those are things like the day or date. So I can check out the day, and it's going to be the 2nd. Or I could check out the month, and that's going to be the 1st. And notice these are attributes. I'm not actually calling here with close parentheses as methods. These in particular are just attributes of that actual date time object. So that's the very basics of a date time object that's built into Python. Now with pandas, we're going to be dealing with a date time index. So you're usually going to be dealing with a time series as an index when working with pandas data frames obtained from some sort of financial API or just reading in some CSV file. Now fortunately for us, pandas has a lot of functions and methods to work with time series data. So first, I'm going to create an example of a date time list or a date time array. So let's just say first to, and I'm going to create a list of date time objects. So we'll say date time, and I'll pass in, let's say the 1st of 2016, so January 1st, 2016. And then I will also pass in as a second item in this list, date time, and let's just say the very next day. So January 2nd of 2016. I will run this and then say first to. So here I have just a normal Python list of date time objects. So again, if you check the type of this, it's just a list. So I have a list of 2 date time objects, and what I can do is then convert this into an index. So as we know, we can just convert a simple numpy array or a simple Python list to an actual index. So we'll say dt underscore ind is equal to pd dot, and notice here I'm going to say date time index. I just use tab to autocomplete. And this is important to note, it's not just an index call. I'm actually telling pandas, hey, this is special date information. It's not just a normal string or normal number. So I can say pd.datetimeIndex, and then I'm actually going to pass in that list, first to. So now if I take a look at dtind, that datetime index object, it's now clarified that, hey, this is a datetime index. And a lot of times we won't actually have to manually create our datetime index in this format, but in case you get some funky data, you may have to do this, so it's good that we go over it. And we can see here now it's kind of formatted a little differently. We can see the dates here, and it says, hey, this is date time 64-bit with nanoseconds. There's no frequency, and we'll discuss frequency later on when we discuss frequency sampling. But here we can see we have datetime index, and let's attach some random data to it. So I'm just going to use np random.randn, and we'll say 2 by 2. And let's take a look at that data. So here I have a random 2 by 2 array. I'm going to create 2 columns, just A and B. And then let's create a data frame. We'll say df is equal to pd.dataframe. Going to pass in that random data I created. And then as my index, I'm going to pass in dt underscore ind. And then I'll pass in my columns that I just created. All right, so here we see our data frame, and of course, as a quick note, you probably don't have the same 4 numbers here that I do because I didn't set any sort of seed for our random number generator. But this is the main format you're going to see a lot of our financial data in. It's going to have the index be some sort of date time object, and then our actual columns will just be the data points themselves, things like the price of a stock or the price of a future, that kind of thing. So now that I have my data frame and its index, I can actually take different arguments from it or call different methods on it. I can say something like df.indexArgMax, and if I report that back, it says 1. So what does that actually mean? Well, it means the index at position 1, and remember indexing starts at 0, so we see this is 0, and then this is 1. That is the maximum or the latest date, and that is the 2nd of January 2016. And if you actually wanted the value itself, you could say df index max, and this will return the actual timestamp itself, 2016, January 2nd, and you notice it has no hour, minute, or second information that we provided, so it defaulted to 000. And if you want the earliest, you can do the exact same thing. So df index argmin, that returns the index location of the minimum. If you actually want the minimum value, you'll say df index min, and that returns the actual timestamp. Okay, so very basic here. Main ideas I want to get across is a lot of your data is going to be in this format, and because it's in this format, there are special properties you can grab from these datetime objects. Those special properties being things like just calling attributes such as what is the day or what is the month. Later on, we're going to get a lot more practice with formatting date-time indices, actually shifting it, calling frequency, sampling, etc. But these are just the very basics, and it's also important to note, in case you ever get any errors with datetime, remember it's from datetime, import datetime. Okay, thanks everyone, and I'll see you at the next lecture. Welcome back everyone to this lecture on time resampling. We'll usually get financial data that has a date-time index on a smaller time scale. That is something like every row corresponds to every day or every hour. However, it's often a good idea for analysis purposes to aggregate the data based off some sort of frequency, such as doing an aggregation on monthly data or quarterly data. Now you may think that using a group by could solve part of this issue. You would just simply do a group by and then group by every 3 months, and that will give you quarterly data. However, a simple group by statement isn't really smart enough to understand things like business quarters or business year starts, or the fact that a business week starts on Monday instead of Sunday, that sort of thing. Luckily, Pandas has frequency sampling tools built into it to actually help with this sort of problem. To learn about this, we're going to be using a stock market data set of Walmart prices. It's located under the time data folder under the 5-pandas with time series folder that corresponds to this section of the course. Let's open up a new Jupyter notebook and get started. Okay, here I am at my Jupyter notebook. I've imported the usual suspects here, numpy, pandas, and matplotlib, and we're going to continue by reading in our data. I'm going to show you 2 methods of reading in the data. One is a little longer and it's a little more customizable. The other one is a little faster. So what we're going to say is df is equal to pd.readcsv, and then we'll pass in the actual file path. Depending on where you are, your file path may be different, but I'm just going to say time data Walmart stock CSV. This matches the notes, and I will read this in. And if I check out the head of my data frame, I can see I have a couple of columns here, and note here that there's a date column, and the date column is what I actually want to be the index. So if I take a look at the date column, or actually if we take a look at the entire data frame, which is df.info, I can see the date column is actually says non-null object, which indicates that this is still just a string. It's not a datetime object. So we need to convert this to a datetime object, and that's actually quite simple with pandas. There's different ways of doing this, but the simplest way is to say df date and set it equal to pd, and there's a special toDateTime function, and then you can pass in an entire series such as the original date, and what this is going to do is you're passing in the original series of the date, which is just strings, and pd2datetime is going to reformat it to be a datetime object, and then it'll set that to dfDate. Now luckily for us, this string is already in the standard notation. It expects a year dash a month dash a day. But in case you have a different notation for your specific date string, what you can do is under pd2datetime, if you do shift tab here, you'll notice there's a format argument. And this format argument basically takes in a string that essentially tells pandas what format it's in. So if you scroll down here, there's an example of what that string would look like. So we'll keep scrolling down till format. So this is just a string telling you what format to expect it in. So in this case, this sort of string says, okay, expect a day, then a /, then a month, then a /, then a year. And there's actually different types of special characters that start with those % signs that tells pandas what kind of day or what kind of month to expect. So for instance, the difference between % sign lowercase y are the last 2 digits of a year, % sign uppercase y, those are the full 4 digits of a year, etc. And you can look this up in the pandas documentation or in the provided notebooks for what these key terms are, this % sign key term. Luckily for us, we don't really need to provide that information because it's already in the standard format. So we're just going to hit enter here and then check out the head of our data frame. Notice it looks the same, but when I say .info, I can see that it's now a datetime object. So we have that ready to go. Now, another way you could do this possibly is instead of saying pd2datetime and then pass in the series, you could also just apply pd2datetime to every element in the series. So do something like date apply and then call pd.toDateTime. I've seen that as well. And then you just set something like this. So it's really up to you. These perform the exact same function. I would recommend doing it this way with pd2datetime and then passing the series. To me, that's a little more readable, but either way should be fine. And let me delete everything in the cell and then clear it out. Okay, so we have our new date column, and it's now no longer just a string, but it's actually a date time object, which means we should be able to set it as the index. So I can say df.setIndex and then pass in date. I also want to call this in place be true. So if I take a look at my data frame, I can see I have now the date time index and then the various columns. So that's kind of the longer, more manual way, but it gives you a lot more control, especially with this PD2 date time. Lets you have full control over whatever format the date's in. If you actually want to read in the date as an index since the very beginning, you could have just up here specified pd.readcsv, and you can also add in an argument index_column and specify that the index column is the date. However, keep in mind that this will still read it in as a string, and you will have to reformat the actual index to be a datetime object. Now, an additional thing to note here is that pandas actually comes with another parameter you can add into readcsv that will actually do this parsing of dates for you. And that's going to be parse_dates, and you can set it to true. And what this does is if you provide an index argument, such as set the date column to be the index location, parse dates set to true will automatically try its best to parse this column as a datetime object. So let's try this out. We'll reread our data frame. And then if I check out the index, it is now a datetime index. So this is the faster way. It's not as controllable as the way we just showed with the step-by-step, but if your data is already in an expected format, this will save you a lot of time. You just pass in your data, set the column date, and then say parse dates equal to true. There's other things you can do with parse dates, such as adding in an actual list of columns to try to parse, things of that nature. You can always check out the documentation for more details. So we'll just stick it with this way, index column parse dates equal to true, and I'm going to scroll all the way down here, come back to our df, hit enter, and everything's the same. So let's continue along and start talking about time resampling. So to do any sort of time resampling, we're going to need a date time index. So if we scroll down here all the way to this next empty cell, again, just as a reminder, we have a date time index. What I can then do is off this data frame, say resample, and then provide what's known as a rule. And the rule is just indicating how do you actually want to resample this data. So for instance, I can say rule is equal to the letter A, and then if I run this, it'll say, okay, you have date time index resampler. And this is essentially acting as a group by method specific to time series data, that is date time objects. And there's keywords for every kind of possible series offset that you could think of. So I'm going to bring in a little table that's available to you in the corresponding notes for this lecture. So let me bring it in from my right hand side of the screen. So there's a little table here. This is available to you in your notes. And there's an alias corresponding to every single type of description. You can see there's dozens here that are very, very useful. We're just using A, which is year-end frequency. So we can expect the last day of the year as our resampling. So we'll bring this aside now. And you'll notice here you have a date time index resampler saying, okay, it's resampling based on the end of the year, but any sort of resampling is going to need an aggregate method to actually give some sort of result, which means essentially operating like a group by, you can then say something like mean. And now what this will do is it gives you the mean value based off the resampling of the end of year. So everything before 2012, 12/31 had a mean of 67. Everything between 2012, 12/31 and 2013, 12/31, aka the end of year, had a mean of 75, etc. And you can just keep doing this for a different resampling. So I can do another resampling rule. Let's try doing a quarterly one. So you would look up in that table, and then you would realize it's Q. Some of them have obvious letters, some of them don't. And then you would get now quarterly resampling. So here we have quarterly resampling. And then you can also do business quarter end frequencies. So you can do something like BQ for business quarters and grab the means based off your business quarters, which may slightly end the dates if it's end of quarters a Friday, that sort of thing, instead of just a random Saturday. So that's important to know as far as the different rules that you can apply. And you can actually also apply your own custom functions to any of these resamples, just as you could with any group by method. So let me show you what I mean by that. I'll scroll down here. If I say resample, and I give it the rule to be, let's just do end of year again, and I ask for the max, that's going to return the max price per that year, basically ending it on the last day of the year. But let's say I actually wanted to return the first instance of the period, regardless of any sampling rate. What I can then do is, instead of max, I'll define my own function. Or you could even do this as a lambda expression, depending on the complexity of it. I'll create a function called first day, and it takes in some entry. In this case, we kind of expect the series here, and then it's just going to return entry 0. So indexing the very first entry off of this. So this is called first day, and instead of doing max here, once I've ran this and defined first day, I can say, okay, take my data frame, resample it based off the year end, and then instead of calling max or mean or standard deviation, that sort of thing, I will just apply my own kind of time series function, which is called first day. And note, I'm not calling it, I'm just passing it in. So I'm not executing it with parentheses, I'm just passing it in like this. So now what this does is it returns the very first sample or entry for this particular time period. Okay, so let's show you what you could do with visualization with these resamplings. It's not super common to have to do your own applications this way as far as doing a .apply, because most of the things you want are already built in, but just keep that in mind, it is possible. Moving along to the visualization, just want to show you kind of two quick visualizations illustrating why you would want to do something like this. Let's say you actually wanted the kind of yearly end mean. How would you do that? Well, you could ask for the close column, and then you can call resample not just off a data frame, but actually off the series or the column itself. And then we'll resample with A, and then I'm going to ask for the mean of the closing price, and then I'm just going to do a bar plot. So we'll say plot kind is equal to bar. So you can see our output here gives us a nice little bar plot indicating the mean or average for those years themselves. And we can kind of edit this to resample, for instance, by the month. So let's say M here. And if I run this, now I get this monthly kind of average. So you can see there's a big dip in sales there. Now formatting wise, you're going to use all your matplotlib skills to reformat this. But we could also do something like just set a bigger fig size. So I'll set fig size 16,6. I don't know, that may be quite large, but okay, here we go. And it's kind of a nice little figure here. We can see the dip in monthly sales, etc. So that's the kind of thing you would be using for resampling. Now note that I'm using a bar plot because technically these are all categorical points. This is not a continuous value because the dates are actually holding some sort of aggregate method on them. So keep that in mind. This is not a continuous plot. This is a bar plot. So it's a little different than something like a histogram. Okay. Thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Stock Market Analysis Capstone Project. I want to welcome you to your first large project. This project is going to guide you through using all the skills we've covered in the first half of the course. The first half of the course really focused on teaching you the basic libraries that we're going to be using throughout the course. Things like numpy, pandas for data analysis, matplotlib for visualization, etc. And also using things like stats models for time series analysis. The second half of the course is going to focus on using all those skills in financial analysis situations as well as algorithmic trading. Everything you need for this project is located under the folder Stock Market Analysis Capstone Project, which is in the top level of that zip file. There's an exercise Jupyter notebook as well as a solutions Jupyter notebook. There's also some CSV files you can use in case you need them. I want you to note that this project exercise is optional. You can basically treat it as an exercise where you open up the exercise notebook, work through it, do the reading, and then answer the questions in it. Or you can treat it as a code-along project where you go with the solutions lecture coming up next and actually just follow along and code along with me. Whatever your style preference is, go ahead and go for it. Now there's a few bonus tasks inside the exercise notebook, such as the candlestick visualization, that require exploring the documentation. There's a couple things to do some of these bonus tasks that we actually haven't covered yet. So feel free to skip these and wait until the solutions lecture to actually see how they're done. Or if you're feeling up to the challenge, go ahead and go for it. Another major part of this project is to slowly introduce a few new financial concepts to get us ready for the second half of the course. These are just basic things like returns and cumulative daily returns. The methods for these financial analysis techniques, they're described really thoroughly in the notebooks, so quite a bit of reading will be involved with this project to make it a full learning experience. So when you're learning how to actually calculate the cumulative daily returns, there's some things to read in that actual exercise notebook. And one last note, the notebook will want you to use Pandas data reader in order to actually get stock information directly with Pandas from the internet. However, for some geographical locations, or if your computer has a firewall, or maybe you don't have full admin settings, that may actually limit your use of Pandas data reader. So all the CSV files that you're going to be using are provided just in case you need them. Alright, let's explore the exercise notebook and walk you through it so you can decide how you would like to approach the project, either as a full exercise or as a code-along solutions project. Let's hop over to the exercise notebook now. Okay, under the Python for Finance repo folder, you have the Stock Market Analysis Capstone project. You can go ahead and open up this Stock Market Analysis project notebook. And then the corresponding notebook for it is the Solutions notebook. Don't click on that unless you actually want to see the solutions. Instead, click on Stock Market Analysis. That will open up this notebook. And here we have the Stock Market Analysis project. And then here's the note again. You're free to treat this as a full exercise or just view the solutions and have it be a code along. So this is your first capstone project. I'm going to zoom out just a little bit so we can read some of the stuff. So it's separated out into parts. So part 0, just importing various libraries. Then part 1, getting the data. So this capstone project focuses on car companies and analyzing the returns of car companies and comparing them to each other. So we focus on comparing things like the Tesla company versus the General Motors versus Ford and how their stock performs from January 1st, 2012 to January 1st, 2017. So we're just dealing with historical data here. So we have getting the data, so using Pandas data reader. Again, in case you can't use Pandas data reader, we have the CSV files for you. So it walks you through getting the data, and then also wants you to repeat this step for Ford and General Motors. So then once you get that data, there are some visualization tasks. So we want you to visualize things like a basic plot of what the stock performance looks like. So you can see here Tesla much higher than General Motors and Ford, although keep in mind this doesn't take into account things like total market cap. This is just price per stock. Then I also want you to plot the volume of stock traded each day, things like that. And then there's a little bonus question, what happened that day. So these little bonus questions require you to do a little bit of Google searching. So for instance, Ford has a really big spike in late 2013. I want to ask like what happened that day, like what is this day, etc. And an example answer is right there. There's also some more questions here, trading, total traded, etc. More plots, moving average plots, we've discussed those already. Scatter plots, which we've also discussed, seeing trends, etc. Then there's this bonus visualization task. This is really hard. Well, not really hard. It just requires you to kind of check out this finance demo documentation. And eventually, if you actually end up doing it, you'll get a little candlestick plot that looks something like this. Now, we haven't actually covered how to do this yet, so always feel free to kind of skip this bonus task here. So going along, we come to part 3, which is the basic financial analysis. So this is where we actually begin to focus on a few key financial calculations. Nothing too crazy, just things like daily percent change, which is the daily percent change formulated by the price at time t divided by the price at t minus 1 minus 1. So the ratio of the current price divided by yesterday's price minus 1. And that's your return, which makes sense because it's basically the ratio of how much you made from yesterday. And then you'll calculate returns, you'll keep going down, do some more stuff with moving averages, etc. You'll do some histograms, kind of measuring volatility here of the various stocks, compare them one on top of each other, some more visualizations, you'll do some kernel density estimation plots, you'll do some box plots, etc. You'll compare daily returns between the stocks, see if something's correlated or not, so you can see kind of Ford and GM have a higher correlation versus Tesla, and then you'll have cumulative daily returns. So there's a little bit of reading here for you to do in case you don't know how to actually calculate cumulative daily returns. There's a little bit of an explanation of a daily return versus a cumulative return. There's also some formulas here you can follow, and here's the formula here, and then here's the actual Pandas formula that you'll be using. So you'll do that, you'll calculate it, you'll get the returns, and then the cumulative return, and then you'll plot them out, and that's the end of the project. If you have any questions, feel free to post them to Q&A forums or just check out the solutions lecture where I'll be explaining everything in a lot more detail as we actually code through the project. Okay, best of luck, and remember you can approach this project however you feel best works for you. I'll see you at the solutions lectures. Hello everyone, and welcome to the first part of the solutions for the stock market analysis project. let's hop over to the exercise notebook and get started. Okay, here I am at the notebook. I'm going to scroll down a little bit. And the first part is just import the various libraries. So part 0, we're going to say import numpy as np, import pandas as pd, and since we know we're going to do visualization, we'll say import matplotlib.pyplot as plt. And in order to see the visualizations inside my Jupyter Notebook, I will say matplotlib inline. So we'll run that. And part 1 is getting the data. So as a quick note, in case you weren't able to use Pandas data reader, you can always just do read CSV and grab the Tesla stock CSV files. But we're going to walk through it with Pandas data reader. So the first thing I want to do is say import Pandas data reader. And then I'm also going to import date time in order to set the actual dates. And then the last thing I want to do is also say import, we'll say import pandas data reader data as web. Okay, so let's start off with the start date. So the start date is going to be January 1st, 2012. So if we can zoom in one more level here. So January 1st is our start. So we'll say start is equal to datetime dot datetime. And we'll say 2012 11. And then we're going to just copy and paste this for our finish or ending date. And then that's going to be the exact same thing, except instead of 2012, it'll say 2017. So once we've done that, what we're going to do is set a variable called Tesla equal to web.dataReader. The stock ticker for Tesla is capital TSLA. We'll use the Google API for this, and then we'll give it the start and end dates. Let it read that, and hopefully we should get the Tesla.head. And there it is. Looks like all our data is matching. Perfect. So now I want you to repeat the same steps to grab data for Ford and General Motors. This is actually pretty simple. We're just going to create two more variables. We'll say Ford, set that equal to web.dataReader. The ticker for Ford is F, just capital F. We'll say use the Google API, and then give it the start and end dates. And we'll do the exact same thing, except instead of Ford, we'll have it be General Motors, and that ticker is GM. And then if we check out, for instance, the head of Ford, that matches up, open at $11. And if we check out the head of General Motors, matches up, opening 20.83. Okay, great. So that concludes part 1, actually getting the data. Should have been pretty straightforward. If you were having issues with Pandas data reader, you can always just use the CSV files. Moving on to part 2, visualizing the data. So what we're going to do is follow along and recreate the plots below according to the instructions and explanations. So the first thing to do is to recreate this linear plot of all the stocks' open price. So hint for the legend, you can use the label parameter and plot legend. So that's an easy way to actually get this legend here to show nicely. And let's actually walk through that now. What we're going to do is say Tesla, that was that variable for the data frame. Grab the open column, so that's the opening price, and then I'm going to plot, and I'm going to give this the label Tesla, and we'll just say fig size is equal to, let's say 12 by 8. I think this one's 16 by 8, but it doesn't really matter too much. And we'll give it the title opening prices here. So that title and that figure size is going to follow along with anything else I plot below this. So then if I do GM open, all I need to say is plot and give it its label. In this case, GM. And then I'm going to say Ford. Again, just the open column. And then I'm going to plot this one as well. So give that the label Ford. And then I need to call pl.legend in order to actually see the results of this, and call it with some open and close parentheses. So if I run this, I should get now the same plot that I saw earlier. So this is the same plot as it is here, just a different figure size. I think 16 by 8 is the actual matching figure size. So there it is. And as a quick note, if you're using Jupyter Notebook, you may get this thing right here where it says legend. If you want to not see that, I believe you should be able to just add a semicolon to the end of this, and then it will hide this output. So if we run this again, there we go. It hid that little legend output. So you can put a semicolon there to hide that. Just a little quick tip. Okay, let's continue along. And now we want to plot the volume of stock traded each day. This is actually going to be extremely similar. So what we can do is just copy and paste from this cell, because essentially what we're doing is doing the exact same task, except instead of plotting the open column, we're going to plot volume. So we'll say volume for this, and then instead of saying open prices or opening prices, we will say just volume traded. We'll switch this out for volume here, and then switch this out for volume there. Run this, and there we go. That's the total volume traded. So you can see it looks like Ford had a really big spike somewhere in late 2013. So in late 2013, you can see this huge spike. It's well above anything else. So you can see here, this is 1.5 times 10 to the power of 8. That's this line right there. If we zoom in on this line, this is above 2 times 10 to the power of 8. So this is huge. So what we want to know is, what was the date of this maximum trading volume for Ford? So this is where pandas comes into play. And then as a bonus question, what happened that day? So let's actually check this out. So in order to figure out this timestamp, what I need to do is figure out where's the maximum of the volume being traded. So let's go ahead and just do that with Ford. And what you might think to do is just get the max here. But if you just do max, that's going to return the actual amount. So ended up returning back how many units of stock were actually traded, 220 million. If I want the actual date, I need to use argmax. Then it returns back that it was December 18th of 2013. Now to answer the bonus question as far as actually what happened this day, all you need to do is essentially Google search Ford plus this date, so 2013 December 18th, and you'll end up getting a bunch of news articles, and there's links in the solutions notebook that say things like aggressive Ford plans hit profits, shares fall. So what ended up happening is that day or the day before, Ford basically made an announcement that the cost of launching new products would cut into next year's profits. So that ended up causing a big sell-off, and you can see the big sell-off happening on that particular day. And if you kind of take a look at Ford by itself, so if you take a look at Ford's opening price, and then plot that, let's give this a fig size of, let's just say, I don't know, 20 by 6. If we take a look at that actual date, it's kind of late 2013, you'll end up seeing the drop right here. Now, in context of this entire huge time period, it's not actually such a huge drop, so it's not as noticeable as the spike here. So keep that in mind. And what's fun to do is kind of take a look at these other spikes and see how it corresponds with the actual dips. So you can see there's a much larger dip kind of in mid-2014. So if we take a look at mid-2014 over here, we end up seeing a little spike here. So not as significant as this large spike. So just kind of interesting things to check out as you're kind of playing around and visualizing this data. Okay, so the open price time series visualization, that is, if we look all the way back at this first one, right here, where we see Tesla's huge stock price versus General Motors and Ford kind of laying flat. That visualization makes it look like Tesla's always been much more valuable as a company than General Motors and Ford. But to really understand this, what you actually need to think about is the total market cap of the company. That is, not just the stock units themselves, but the stock price multiplied by how many available units of stock there are. That's the market cap of the company. So our current data doesn't actually have information of total units of stock in the company. It just has volume traded. So what we're going to do is just, as a really simple calculation, try to represent the total money traded. That's going to be multiplying the volume column by the opening price. And remember, this still is not the actual market cap. It's just a visual representation of the total amount of money being traded. So basically, 100 units of stock at $10 each versus 100,000 units of stock at $1 each. Just how much money is actually being traded for each of these companies on these given days. So first off, I wanted you to create a new column for each data frame called total traded, which is the opening price multiplied by the volume traded. And this is not a real technical analysis, so we usually wouldn't do something like this. This is mostly just to explore your Panda skills. So we'll say Tesla total traded, and we'll set that equal to Tesla the open price of the column, and then we'll say Tesla, the total volume traded. So essentially what we're doing is we're trying to get an idea of more or less how much money was actually traded. Now, again, this is not an exact calculation because the opening price is not the average price for that day. You can do a lot better estimations than what I'm doing here. Again, this is kind of just to practice our Pandas skills. So we're going to copy and paste this and do this for the other two. So that's going to be Ford, it's going to be Ford, and this is going to be Ford. And then this last one's going to be General Motors, General Motors, General Motors. Okay, so we have 3 total traded, and now we're going to plot this against the time index. So all we're going to do is basically copy this total traded column, and then say dot plot, and we'll give this the label Tesla, and let's give this the fig size 16 by 8. And then we'll say General Motors, total traded, plot that with the label GM, and we'll then say Ford, total traded. I'm just using tab to autocomplete there, and we'll give that the label Ford. Let's add in our legend, PLT legend, and then let's put a semicolon there. Okay, so this is essentially a visualization of the total amount of money being traded. So now you can see that Tesla is a lot closer throughout many of the actual years. Now there is a huge spike for Tesla. So on this particular day, there's a huge amount of money being traded for Tesla, which we can explore later on. But as far as the difference between this particular visualization, and if we scroll back up, this particular visualization, the actual amount of money being traded is a lot different. So again, the opening price, the actual individual price per stock unit, is quite different between Tesla, General Motors, and Ford. But again, this doesn't do a good representation of total market cap. Now, total market cap is not something we can actually get from the data we have at hand here. All we have are the open, high, low, close prices and volume, but we can kind of get some sort of idea doing kind of this crude calculation of open price times volume. This is, again, not a market cap, but more of the discussion on how much actual money is being traded each day for each of these companies. And you can see here that for a lot of these days, a lot of money is being traded around for all of the companies. Now, Tesla, again, quite a bit more money being traded around, especially during certain years when it was being shorted a lot for various reasons. But Tesla is also kind of a crazy company when it comes to its stock price, so just keep that in mind. So going around, what we're going to do is continue on. And if you keep continuing on and scrolling down, you'll end up seeing it says, interesting, looks like there was a huge amount of money traded for Tesla somewhere in early 2014. So that's this number right here. You can see there's a huge amount of money somewhere in early 2014 that's being traded. So what we want to do is, what was that date and what actually happened? We are actually going to do a really similar thing to what we did earlier. We'll just say Tesla, grab the total traded column, and then I'm going to ask for argmax. And that should return February 25th of 2014. So what actually happened that date? Well, if you end up Google searching this date plus Tesla, you end up finding news like this where it says Wall Street Journal, Tesla shares surge on Morgan Stanley report. So essentially what happened is some Morgan Stanley analyst gave a good report on Tesla shares. So that caused a huge spike that particular day. So what we're also going to do is practice plotting out some moving averages. So I want you to plot out the moving average 50 and then moving average 200. So let's go ahead and do that. That's going to be actually quite straightforward. We'll just do this for General Motors, not all the stocks, as it says in the instructions. So we'll say General Motors, call it MA50, that is the 50-day moving average, is equal to GM, open, and all I have to do is call the rolling method on this, 50, and then ask for the mean. And it's kind of up to you whether you want to set this as a new column or not, but setting this as a new column in the original data frame allows us to kind of do a nice little call at the end and get the legend automatically. So this one's going to be moving average 200, and that will be equal to GM, the open column, rolling 200 days. That's quite a large window, just keep that in mind, this is more for visualization purposes. And then let's actually just pass in a list of columns. So we're going to pass in a list of columns. We'll say open, MA50, and then MA 200. And then we're going to plot this and give the label, actually we don't need any label really. We'll just say fig size is equal to 16 by 8. So let's run this, and we should see the same plot result here. So we can see the opening price, which is blue, the moving average for 50-day moving average, kind of getting that trend, and then the even more macro trend, which is the 200-day moving average. Okay, so again, quite a large window of 200 days, a little more for visualization purposes. But you never know, certain technical analysis techniques require really large windows. So finally, what we're going to do is see if there's a relationship between these stocks. After all, they're all related to the car industry in some form or another. So we can actually do this easily through a scatter matrix plot. So what I want you to do is import scatter matrix from pandas.plotting and use it to create a scatter matrix plot of all the stocks' opening price. Now, something you may need to do is rearrange the columns into a single data frame. And there's some hints and info, so if you check out this link, there's hints and info on how to actually use the scatter matrix plot. So you can come over here to the actual documentation, and it'll describe how to actually use scatter matrix and give you some visualization examples as it loads up there. Let's hop over to the Jupyter Notebook and actually do this ourselves. So we need to say from pandas.plotting import scatter matrix. So I will import that, and then I'm going to create a variable called car companies, and I'm going to just concatenate a couple things. I'm going to concatenate the open column of Tesla, and then the open column of General Motors, and then the open column of Ford. And I want to do this along axis is equal to 1. Because, whoops, axis equal to 1. And if I just take a quick look at what I've done by checking out the head of this, I essentially just concatenated 3 open columns here. So Tesla, General Motors, and Ford. So this actually doesn't have any column names yet. They're all open, so let's change that. They're all still in the correct order that I concatenated them, Tesla, General Motors, Ford. So let's define this as car columns, and we'll say Tesla open, General Motors open, and then Ford open. We'll run that, and now if I see car companies, the head of it, I get this nice little Tesla open, General Motors open, and Ford open. And now what we're going to do is just use a scatter matrix to create this plot right here. So we're going to say scatter matrix, pass in our data frame, which is that car company data frame. And we can set the fig size to really whatever you want. I'll just say 8 by 8. If you're not as zoomed in as me, you won't need to do that. And I'm just going to run this, and we'll go over a few more arguments. So if you just run that, you end up seeing kind of this big thing of array telling you the matplotlib axes, and then you get something that looks like this. So there's a couple things you can do with this. I'm going to zoom out just a second so we can see the whole scatter matrix plot. We can see that there's a clear positive correlation between General Motors and Ford. Tesla is quite a bit different, has some different behavior, and that makes sense because we saw there was kind of a huge jump in Tesla's stock price while General Motors and Ford kind of stayed at the same level in comparison. What you can do to kind of get a better idea of this scatter plot is add an alpha variable. So we'll say alpha is equal to, and let's just say 0.2 because we're dealing with a lot of data points here. And now it's going to appear much darker where there's more points stacked on top of each other. So that's something you can do. And if you want to actually add in more bars to this histogram, what you end up doing is you add in as an argument HIST underscore KWDS. And this is going to be a dictionary. And what this dictionary represents is these are histogram keywords based off matplotlib's own histogram. So what you end up doing is you go to matplotlib's documentation, check out the keyword arguments for using a histogram of matplotlib, and you can pass these in as a dictionary. So the one we are concerned with is bins. So that's the parameter, colon, as the value you give it the key you want. So 50 bins. And I think I misspoke. I said the key you want. You just want to give it the value you want, not the key. The key is bins. Value is 50. And if you want to get rid of this array, you can just use a semicolon again here. And there's our scatter matrix. And that basically concludes part 2. There is a bonus visualization task, but we'll do that in a separate lecture. That was the main visualization tasks you had to do for this exercise. Coming up next, we'll tackle this bonus visualization task, and then we'll move on to part 3, basic financial analysis. If you have any questions, feel free to post them to the Q&A forums, but also make sure to check out the solutions notebook for the full code and explanations. I'll see you at the next lecture.